So without further ado, let me introduce our first speaker, Anirudh. So Anirudh, can you turn on your camera? Okay, our first speaker is Anirudh, of course, Anirudh Srinivasa Raghavan. Sorry about that. In any case, you can introduce your name later again because my pronunciation is not good. And this research is an Android app that implements two of our bio-inspired algorithms that are trying to analyze users' wandering behavior in the past, and then compare these patterns with other users to recommend a point of interest or point of interest category to the users. And all the data the app collected is anonymous and hashed. So even ourselves, we will not be able to know anything about the users, but our system can try to make a recommendation for them. So let's welcome Anirudh. Anirudh, the floor is yours.
Yeah. Let me know when you can see the screen.
Yeah, I can see the screen.
So hello everyone, I'm Anirudh, and first of all, thank you so much for taking your time to attend this presentation. So the research outcome is a mobile app, like Sir told. It's an OpenStreetMap based next stop recommender. And yeah, about me, I'm an undergrad student in PS Institute of Technology. I'm studying computer science of engineering, and I'm in my 4th year right now. And about a project guide, he is a professor at Athabasca University in Edmonton. So first of all, before we start the research outcome, the users, first of all, everyone should be knowing some things about the research outcome, which is very specific to it. First of all, it's a point of interest. Point of interest is something, a place which is of a public interest. It can be a restaurant, it can be a retail shop, or it can be a grocery store. It cannot be your house and my house because that's not of a public interest. So that's a point of interest. So an example for a point of interest could be a cinema theater, or Cinepolis Mall, something like that. Next is hashing. So hashing is an algorithm which actually tries to map any data that's given to its input into a message of fixed size. And it's impossible to reverse the computation. So if I say hello world as my input to the hashing algorithm will give me back this string, which is of fixed size. The length of the hashing algorithm depends on the type of algorithm used. There are so many things in the market like MD5, SHA-256, SHA-512. And with just given this hash, I cannot reverse it back to hello world. It's really impossible to do that. So that's the beauty of it. And finally, let's start with a research goal. So the first goal is to design a mobile app that can detect users' location periodically and store the point of interest in the database. And second thing is it should work offline without having internet functionality, because if we are on the streets, chances are there will not have internet connectivity, will not be connected to mobile data. So the app has to handle working without internet functionality also. The third is to implement two recommendation algorithms. One is based on the point of interest, another is based on the category. So these are the applications that are developed as a part of this research outcome. The first is a web technology-based dashboard and a landing page. We use HTML, CSS, JavaScript, PHP, SQL, and AJAX. And second is an Android app that can actually do what our research outcome does, like collect point of interest and get recommendations for that. So we use the Android Studio, PHP, SQLite, XML for that. So there are 3 stages in the research outcome. The first stage was to develop the mobile app. Second was to make the OpenStreetMap synchronization service to make sure that the app functions even without internet connectivity. The third stage was to actually develop the recommendation algorithm, the 2 algorithms that we discussed before. So let's start with stage 1, the mobile app development. So there were 6 tasks in the stage 1, the mobile app development. So first was the device registration. Second was to record the point of interest. Third was to make sure that the algorithm detects if the user is staying in that place or is just moving around that place. The fourth is a way to actually collect the point of interest and manage them. The fifth is trying to synchronize between the local storage and the server database. And the last one is to make an animation to whenever the user is trying to click on get next stop recommendations. So we'll be going through one of them, like one by one. So first is the device registration. So it's not a very simple thing to just register a device. Since we are the main goal of the app is to be anonymous. So the users, I mean the administrators don't know what the user's information are. We can't collect any user's information like name or anything or ID. So everything has to be anonymous here. So how do we do that is we have a mechanism for that. First of all, the first thing that we need is we need a unique ID that's given for each and every device, so we can recognize that device uniquely. So for that, we had to do something. We had to make the server generate a unique UUID and give it to the phone. But then anyone else can, let's say that a phone is trying to send a request to the PHP server. The PHP server should have a mechanism to know if the request is coming from the phone or if someone else trying to spoof that request. So for that, we had to do something called CRC check, which we'll be showing in a few minutes. So how the device registration works is, first a signature is created for that particular phone. So what's a signature? Signature is a unique, let's say a unique identification for that particular phone. So what are we trying to take for this registration? For the signature here is we're trying to take the product name, which will be the mobile phone name, mobile phone's ID, display name, IP address when it was trying to connect to, when it was trying to register. And finally, the epoch time. Epoch time is the time in milliseconds since 1970, January 1st, 1970, the number of milliseconds that have passed. So it's very unique. Like if you try to take the combination of it, it's going to be unique enough for each and every device that's trying to connect to the server. The signature is going to be stored both on the app side and the server side as well. And we'll be using this for the CRC checks. And finally, like we don't need to replicate this every time whenever we're trying to use the app, because this is only a one-time thing. So let's say that the user goes and tries to connect to a different internet connection. The IP address would change, but still the signature is already stored in the device whenever the app was created. So we don't have to do anything. This is just a first-time thing. So let's just take a scenario here. So Arjun is a casual wanderer and is often clueless on the next place to visit. So he's trying to use our next stop recommendation app to get recommendations. So how does the registration happen? So first, the phone has these particular details: the product name, the product ID, display name, IP address, and the epoch time when it was trying to connect. So all these things will be sent to the server. And the server is going to use this and it's going to concatenate it. So this is how the string after it's concatenated looks, and it's going to be hashed. And the final hash string is the signature. Now, the server is also trying to generate a unique UUID. So let's say that the unique UUID in this example is this. And then what the server does is it's going to compute a CRC. A CRC is actually trying to check if that particular request is coming from that device. So what we do is we hash the UUID given here. This is the UUID generated, and the signature which was generated from the previous slide. This signature is going to be concatenated again, and it's going to be stored as CRC. This CRC and the UUID is going to be sent to the phone. So what happens now is the phone will try to create its own CRC, which means the information it already had here, it will try to make its own signature. So it already knows, the server knows that the signature is just concatenated thing. The phone also does the same thing. It tries to concatenate it in the same way. And then it tries to create its own signature. And that signature is going to be concatenated with the UUID to get a CRC2, which is actually a phone generated CRC. And it tries to check if these two CRCs are matching. Only then the registration is complete. If not, the registration will be repeated again. So this way we can actually validate a request which is coming from the phone itself. The right device will get access to that request. And if it's not, it's going to be rejected and the registration is going to happen again. So there's a process flow diagram here. So user opens the app, it checks if the UUID is already present in the local database. If it's not present, it's going to send all these details to the server. The server is going to make the signature, and the server is also going to create its own unique QID, and it tries to make its SHA and send it to the phone. The device will make its own SHA. The device will make its own CRC, and it checks if the CRC that's given from the server is matching. If it matches, then it's the end of the registration process. So that's about the registration process. Next, after the registration is done, so now we need the offline data. Otherwise, we'll not know where how to access and how to record the point of interest without the location data. So we ask the server for the location data. After the registration is complete, the app requests for location data. The server is going to download the location data if not available. The server is going to download it from OpenStreetMap server, and it's going to be sending it to the phone. So by default, the prefetch distance is 15 kilometers. That means that the location data 15 kilometers around the user is going to be downloaded and is going to be given to the phone. And users actually can change this distance in the configuration page. So if they want 100 kilometers prefetch data, they can change it in the configuration page. And the location data gets added in the local database in a SQLite format. This step needs internet connection because we are trying to get it from the server. Once the location gets downloaded, internet is not needed anymore. So point of interest can automatically be recorded. And finally, when recommendations can be calculated based on the recorded point of interest. So now, again, Arjun is living in Bangalore and he's requesting for 15 kilometers location data around the place he lives. So the location data looks like this. So the name, category, the latitude and longitude. So all the 15 kilometers, all the point of interest around this place, the 15 kilometers around this place is going to be stored in the phone. So now whenever he's going to a new place, the GPS doesn't need internet connection. So whenever he's trying to go to a new place, the latitude and longitude would automatically be fetched by the GPS, and it tries to record the point of interest, which we'll be seeing in a few slides. So yeah, now the recording the point of interest. So how do we know if the point of interest, like we need to record the point of interest to know the user's wandering behavior. Without that, we can't get to know what to be recommended. So this there are two ways to actually do it, which is given to the users. The user has an option to enable background check, which means that the point of interest can be recorded automatically even without the phone is open or phone is like the app is open in the background. The location data keeps updating and the point of interest keeps updating. Otherwise, if the user does not want to give background location permission, he can directly, like whenever he's trying to open the app, the phone tries to get the location and tries to check the point of interest, and that's how it's going to work. So the location, how the point of interest is going to be recorded is the location is going to be detected periodically. By default, it's set to 15 minutes. The latitude and longitude is fetched, and it's going to be passed to a SQLite statement, which finds the nearest point of interest from the table. The table I said you was this. It's going to find the nearest point of interest from this table, and it's going to check if the location is close enough to the coordinates. Sometimes the closest point of interest can be 1 kilometer away, which can't be our point. The user might not be staying in that point of interest. So we have a threshold, let's say 100 meters. The person is within 100 meters of the recorded point of interest. That if within the point of interest of that place, then we can say, yeah, he's close enough to that point of interest to be there. If the point of interest is found, the app checks if the last recorded point of interest is the same as the current point of interest. If yes, update the state time, or else record the new point of interest in the local database and the server database. So we're going to check the process flow diagram again here. So this is how it's going to work. We detect the location periodically. If the point of interest database is already available, we don't need to wait for the server to process it. We already have it. So we use the SQL query to search for the nearest point of interest, and we check the last detected point of interest name and category. If it's the same, that means you just increment the state time. So the time is staying in the point keeps incrementing. If not, if the point of interest is not the same, you create a new record in the local SQLite database with state time is 0. And if the last record has considerable state time, that means that we send the hashed point of interest name and category to the server. So again, right now the scenario is Arjun wants to test this app. So he visits his favorite restaurant MTR, and he checks if the app is trying to record the point of interest. So here is the demo. So I'll be using fake GPS for just the demonstration purpose. But what fake GPS actually does is it tries to set your phone's GPS to that particular place, And that way we can actually test if the app actually works. So I'm trying to set to the restaurant MTR, and now I open the app. So you see that MTR is actually recorded as a point of interest. Stay time is shown here, which is 0 minutes, because we just started recording the point of interest. And the time and date when it was recorded, it's the timestamp. This is the category. So MTR is a restaurant. It's shown as a category here. And this is how the point of interest is going to be recorded. And whenever he clicks on the point of interest, it's going to open the OpenStreetMaps place, and it's going to show the MTR place. So if he wants to go visit or navigate in the future, he can use that to navigate. And then once the threshold time is reached, the point of interest will be stored in the server database. Why do we need a different database? We need a server database because the recommendation algorithm will be working on the server database and not the phone database. So whenever we try to click on recommend next stop, it's going to take the location recordings from the server database. So whenever the threshold time is reached, we also try to add it to the server database as point of history table with the UUID name category. And you need to note that the name and category is hashed here. So the administrators will not know what place it is. The recommendation algorithm doesn't need to know the name and category. It just deals with data. It just deals with 0 and 1s. So it doesn't care about the name and category being hashed or non-hashed. And that's how this is going to be there. So yeah, just testing here. The hashing algorithm uses SHA1, and we just cross-check if the restaurant's SHA1 is the same as the one shown there. It's category. Yes. And that was about the recording point of interest. Yeah, so this is how the server database is going to store the point of interest. And now about the stay time detection. So stay time is the minimum time a user must stay in a point of interest to be considered for recommendations. So let's say that you just passing through that point whenever you're waiting for a traffic signal. So you wait for a traffic signal for 3 minutes. And if that point of interest is recorded for your recommendations, that would be a bad thing to do. So that's why we have a threshold stay time. And once this threshold stay time is reached, only then the point of interest will be accepted for the recommendation input. So, and the recommendation stay time should be different for different categories. So let's say that the stay time for a park, it can be around 10 to 15 minutes. But for a movie theater, stay time for 10 to 15 minutes does not make sense. We need at least 1 or 2 hours with a minimum of 1 or 2 hours staying in that cinema theater. Then we know that, yeah, the user is actually visited, he's trying to see a movie. And a portal is also designed to update the stay time for all categories, and changes will be updated to all devices, which will be showing now as a demo. So this is the portal. Here we need the administrator just needs to update the CSV, and he has to upload it. So he can download the CSV from that link, which is given there. So the CSV, it looks like this. So there's a category and there's a threshold stay time for each and every category. So whenever he tries to change, administrator can change category stay time for each and every category, whatever he wants to, and he can save it. So now we've changed categories for the first 3 categories. So the bar is 150 minutes, the barbecue 60 minutes, and back garden is 85 minutes. And we upload that file to the portal. And now we can check. The point of interest category is also there in the server database. So here you can see that the dirty bit is set to 1 for the first 3 categories, and the stay time is automatically updated for these 3 categories. So let's also say that if a phone is already using the next stop recommendations, we need to also update the stay time in those devices. So as you can see, I'm trying to run a phone which is already running the app. you can see that the state time is updated here also. So it's using the synchronization service. The state time is updated here too. So you can see that the bar is 150, barbecue 60, and beer garden is 85, as you can see. Yeah, so that was the state time detection. And the fourth task was historical point of interest management. So we need to make sure that the point of interest are recorded in a proper table and uses it is according to the date visited, and users should be able to exclude it also whenever they don't want a point of interest to be included in a recommendation algorithm. They should be able to exclude it. So we need to make sure that we have a mechanism to do that. So Arjun does not want any restaurant recommendations in the app, as he's already convinced that MTR is the best in the city. So he excludes it from the point of interest history list. So how he's going to do is you just have to, yeah, so this is how the list of point of interest will be shown. So the state time is shown here. And clicking on it will obviously open the map pointing to the MTR restaurant in the city. So you can easily navigate to it. And long pressing on it will open a menu where you can exclude it. So there's a menu option asking you if you want to just exclude this point of interest that is visited at this time, or all the records of this point of interest visited totally. So let's say that he visits MTR every day. And if he just wants to delete MTR visited every day, he can just use all to just delete all the point of interest of MTR. So whenever is excluding it from it, we also need to make sure that it's excluded from the server database as well, because the recommendation algorithm is obviously going to be calculated from the server database. So when you refresh, the point of interest is gone from the server database as well. So that was about that. Finally, we need a synchronization checker. Like I told you, let's say that you make some changes when you were offline. The phone tries to add some point of interest or delete some point of interest when it was offline. We need to also make sure that those changes are actually synchronized in the server database as well. Integrity check is an essential process because the recommendation algorithm will provide recommendations based on input from the server database. So how are we going to do that? So first of all, we do the CRC check to see if that request is coming from that device itself. And then the server is going to send all the point of interest recordings belonging to that user, and the device is going to receive it in the array list. So it's going to receive all the list of all the point of interest, and the device is going to check the point of interest that it has in the point of interest from the server database, and it tries to see if something has to be added, it's going to add it to the server database. If something has to be deleted from the server database, it's going to delete it. So it's going to go in a for loop. And we just have a demo to show that the synchronization checker also works. Right now, the phone is offline, and we try to delete the point of interest. We can see that the point of interest is not deleted from the server database. So the third point of interest is still there. So now, whenever we try to get back the internet connectivity, whenever we are online, the integrity check is performed when the app is opened, and it also, so you see that the database is deleted, the record is deleted. So that was the integrity check. And finally, we need a loading screen when the user is waiting for the server to provide recommendations. Sometimes the recommendations can take some time, so we need a loading screen for the user to see something. And so this is the loading screen that was designed. It was designed frame by frame, and it was put in Android Studio. Okay. Yeah, so this is the loading screen, as you can see. So that was about the stage one. So about the mobile app development. Second thing is designing the OpenStreetMap synchronization service. That means since it's going to be offline, we just took 15 kilometers data of the user when he first registered. If the user is trying to move all around the city, we need to have a mechanism to make sure that he keeps getting the offline database whenever and wherever he can. And if he's trying to move from that 15 kilometers range to another 15 kilometers range, we need to provide him with the new 15 kilometers location data. So that's the main outcome from the stage two, which we'll be seeing. So first is the landing page was designed for this project. It's live at nextstop at vipresearch.ca. This is the landing page which was designed. It was done using Bootstrap, HTML, CSS, and JavaScript. And if anyone wants to download the app, they can go to this link and you can just say, get on Google Play. For now, we have not uploaded on Google Play. We are in the process of doing it. For now, it just opens a drive link to the app. And so all the images used here are with the Creative Commons license. And it says about the project and our team. We had our past members in the work on this project way back from 2008. And we also have some videos. So each video is explaining what each stage is trying to do. And we also have some publications for these projects. And then we finally have a frequently asked questions for each and every question which is asked. So that was the landing page. And the second one is a dashboard page. So dashboard page is not for the users, it's for the administrators to see about the recommendation, some metrics and some stats about the recommendations. So first of all, they see this live data. This is actually, all these values are updated real time using AJAX, and it's refreshed every 5 to 30 seconds. And here they see the file status. So every location data that we've downloaded, they can have access to that. They can first of all visualize it. So let's just visualize this file. It's pointing to this. So this is a Bangalore based location data for 15 kilometers, as you can see here. And that was that. And category state time. So this is where the administrators try to update the state time if they want to. You can click on update state time, it will go to that link. And request by city. So let's say that which will be seeing later. Whenever we want to upload offline maps for that particular city, administrators can directly do that. They can see the number of requests coming from each and every city. So they say Bangalore has 46 requests. So they can, based on the traffic, they can make sure that the offline availability for that map is available. Because offline maps is not something that's automated. You have to do it using Atlas Map Creator, open source tool. And then finally, these are the recommendations input. So it sees the frequent patterns and regular expression for categories, which we'll be seeing in some time. And then finally, we also have some bug report. So if the app crashes you with a uncaught error, we just try to send, users have an option to send it to the server and we can try to debug that over here. So that's about the dashboard page. And so next is the offline maps. Like I told you, with offline functionality, users should have an option to download the map of the entire city they live in. So the number of requests from each city can be seen by the administrator in the dashboard page. Traffic can be assessed and the offline maps can be added. So it can be created by a mobile Atlas creator, an open source tool for downloading offline OpenStreetMaps for a particular range. So yeah, this is the demo for offline maps. So right now, Bangalore has 5 requests. Offline availability will be shown as no or yes here. And so whenever you try to upload the location data, so yeah, you can use upload to upload the location data. The location data will be in SQLite format. This is the tool. It's given the OpenStreetMaps. It's called Mobile Atlas Creator. So we can use this to select a particular range to download, and it will download it in SQLite format. You can also download it in various other formats, but the OpenStreetMap OSM Droid, which is the library for OpenStreetMaps in Android, uses the SQLite format to have the offline maps for that particular city. So we use that. So administrators have to do this manually. So once this is done, they can have it up. They can upload it in the upload button here for that particular city. So I'm just uploading the offline map for Bangalore. And now you can open the app. Whenever the app is open the next time, it'll have a trigger telling if you want to download offline maps for that particular city because it's already available. So let's see that now. You can also delete it. So if you have uploaded the wrong location data, administrators can delete that offline map for that particular city. And it says if you want to delete, and if you can click on OK, it'll delete it. So whenever we open the app, yeah. It checks, it'll ask if we need offline map for this. So it says offline map is already available for your city if you want to download it. If you say yes, it'll start downloading it. And you have a progress bar to see if it's downloading. And you can see the location map for that city now. I made it offline now. So the device is offline, but you can still see the offline map for the city Bangalore. So that was about that. Next is so like I told you, every whenever the user is trying to move out of that 15 kilometers range, something has to be automated, and we need the phone to automatically download the 15 kilometers for that next particular range. So we can't ask users we can't have users intervention in this. It should be automated, and users should not even get to know that thing is happening. It should be flawless. So what we do is we have something called cron daemon tasks. Cron daemon tasks are it's a Linux thing where you can schedule jobs for a particular time. You can schedule it every 12 o'clock. You can schedule some job every 12 o'clock, every 1 o'clock, whatever. So here I've scheduled 2 PHP scripts. As you can see, it's one PHP script starts at the 0th minute of the hour, and it goes every 5 minutes. So 0th minute of that hour, 5th minute, 10th minute, 15th minute, 20th minute till 55th minute. And the second PHP script starts 3 minutes later. So it starts at the 3rd minute of the hour, and it goes till the 58th minute. So this is going to be done all throughout the hour, next hour. So it's going to be done all throughout the day. So what each script does is, so yeah, let's see the life cycle of the OSM request. OSM request is the way to get the location data to your phone. So whenever you're a new user or you're not in the range of the previously downloaded location data, you send the request to the server. The server checks if the location data is available. If it is, it sends you back the thing. If it is not, it's going to create a new record in the OSM request table, which has to be processed by the cron daemon task like I showed before. So whenever you have a new request, it will be shown like this. So it says OSM available is 0 and SQL available as 0. So now OSM process, like it's happening every 5 minutes. So it's going to see this request, which is unattended. So it says that OSM available is 0. It's going to download the OSM location data to the server. So OSM location data is using you download it from the OpenStreetMap server in .xml format. And the SQL process is going to see that OSM is available, but SQL is not going to be available for this record. So it sees such records, and it's going to automatically convert all those XML files, it's going to pass those XML files, and it's going to convert them into SQL format. So it's going to add them to a table, and it's going to store them in .db format. And the phone is going to periodically check if the requested location data is already downloaded in the server. If it is downloaded, it's going to import it in the local SQLite database. If not, it's going to wait. And this is how the phone's local SQLite database looks like for all the download locations. So here you can see that we have all the point of interest. We have the categories. We have the latitude and longitude of each and every point of interest. We also have the hash name and hash category, because the recommendation algorithm only deals with hash values. And we need a way to map that hashed value to the actual value. So that's where this is coming here. So whenever the recommendation algorithm is going to give us some hash name and hash category, we're going to map that to the actual point of interest, and we're going to show it to the users. So here is the synchronization service. So synchronization service, like I told you, this service can automatically be triggered even if the phone is even if the app is closed. So app does not have to be running in the background. It's going to be running even if the phone is restarted, even if the phone is shut down, it's automatically going to be resurrected. And so we set run in background, and we set the frequency, synchronization frequency, to be every 15 minutes. And once that is done, so you see that the file to be processed automatically became 1 here. And now I start the stopwatch, and then okay. As you can see,
finish the within 10 minutes.
Yeah, I can present. I'll do that. Yeah, so as you can see, the OSM request will be done automatically without the user's intervention, and it's going to be processed later. Yeah. And finally, the stage 3 is where the next stop recommendation algorithm is actually implemented. So we have 2 recommendation algorithms. One is a point of interest based, and the another is a category based. Finally, we'll see what happens when we visit those recommendations. So first, the point of interest base is going to be taking account of all the point of interest visited by all the users of the app. So we need some terminologies for the recommendation app. So first is support. Support is an indication of how frequently the item set appears in the data set. So let's say that the support of J here is going to be just 1 because it's just repeated once in the whole root. But the support of GA can also be, it's just a subsequence. It's not looking for the sequence. So G and followed by A. So here there's another GA. So support of that is 2. And support of A is also seen 3. It's seen 3. It's seen in all the 3 roots. So it's going to be 3. And then a frequent item set is an item set which has a support value of more than a threshold value. So if the minimum support is set to be 2, then A is a frequent item set because it's repeated 3 times. GA is also a frequent item set that way. And we also have something called rules. So rules is actually going to help us form associations in the item set. So let's say if GA is a frequent item set, then the rule becomes can recommend A, or if the user visits node G, the system can recommend A as the next stop to be visited. And finally, we have confidence. So if a confidence is 100%, that means all the users who visited node G would have also visited rule A. If a confidence is 50%, only 50% of the users who visited G have visited A. So confidence can actually get us more information about that particular item set. So let's have an example here. So let's say this is the root, and this is the root ID. And like I told you, we are going to generate frequent item sets, and the recommendation algorithm is going to work on the frequent item sets only. So frequent item sets are, like I told you, it has a minimum support count. So let's say the support count is more than 2. So we have our frequent item sets here, like one item frequent set, like C, G, A, E, B, D, which have support more than 2. And then they have two item frequent item set, and there's also 3 length frequent item set. All these are generated using sequential pattern mining. So once that is done, we are going to have the recommendation rules. Like I told you, these are the frequent item sets. We can't map one length item set to any recommendation rule because we need a minimum of 2 items in the item set to make a recommendation. So let's say if the user visited A, you can recommend C. If user visited B, A, they can recommend C. So that way these recommendation rules are done. And then finally, let's say we have an example here, like Arjun. Arjun is visiting the node JGCA in the following order. Then he tries to get recommendations for the next node to be visited. The potential recommendations are rule 1 to 8 because A is the last node he visited. So let's say when he visited A, you can recommend C. When he visited A, you can recommend E. Or when he visited GA, he's already visited J in the past. We also have a rule for GA, so we can recommend him E. So these 3 are the recommendation rules which we'll be working on. And we try to find the best recommendation out of this. So we have 2 metrics for that. First thing is called similarity. It's going to check how similar is your root to that actual root. So it's going to see the length of that. It's going to see the length of your actual root. So your actual root is going to be JGCA. Like I told you, this is your root. And so that will be your length of that root. And then the length of that rule, left-hand side rule will be 1, 1, and 2. So this is just telling how similar it is to the actual rule. So how similar is your route to your actual root. Bigger the length, more easier it's for, more similar is that user to your user. So this is one way to actually see if that recommendation rule is good. So here, according to this similarity metric, we can say that GA recommendation rule is pretty good and it's better than the other two recommendations. And then we also have one more thing called conference. Like I told you, conference is if a user visited, what percentage of users who visited A also visited C. That's going to be calculated by conference. So using conference, we can have one more extra metric to tell, yes. So it's not going to be length of the users. It's going to see the confidence of that particular rule. And based on the conference, it's going to see if that recommendation can be given. So finally, based on the similarity and the strength, we add a bias similarity. So bias similarity is a value between 0 and 1, and we try to multiply with that similarity, and we try to multiply 1 minus bias similarity with the strength. So we're just trying to take the best of both the worlds, and then we finally make it into a value called recommendability. So using this, we can have a proper measure to tell that, yes, this is the best recommendation out of these 3 recommendations, and we have that in our order. So this is a dashboard which actually shows the frequent patterns, like I told you before. These patterns are also generated by the cron task. And then finally, we have the last category-based recommendation. So the category-based recommendations is only going to see the user sequence, not the global route list of all the users. So whatever the user has, whatever the user have traveled in the past, it's just going to be seeing that. So how that's going to work is, let's say the list of categories is AB, AB, AA, AB. So the regular expression which can be done for this particular category list is A plus B for the whole plus. So A can be repeated 1 or more times. So because A is repeated 3 times here and A is repeated 1 the rest of the times, so it becomes A plus, and B is just repeated once. And finally, we just have this recommendation. So based on this regular expression, we can say that the next stop to visit after B could be A. If the user has visited A as the last point, you can recommend A or B for them. So that's the intuition for the category-based recommendations. So how this algorithm works is very simple. So it just sees, it tries to split it into 3 different. So ABC, AB, AA, AB. So A is repeated 1 time, B is repeated 1 time, C repeated 1 time, A repeated once, B repeated once, A is repeated 3 times, B is repeated 1 time. And now it's going to see A is repeated 3 times here. So it's going to assign plus because it can be 1 or more times. B is just repeated 1 throughout. So it's not going to assign anything. And C is repeated here. C is as work here, but it's not in these 2 iterations. So it's going to put star because star means it can be repeated 0 or more times. So the final regular expression is going to be that. So based on this, the next category you can recommend can be C, because C can be repeated 0 or more times, or you can directly recommend them the category A. So we have a proper difference between point of interest and category based. We need to note that point of interest does not necessarily give the recommendations from the user's vicinity. It can give you, if I stay in Bangalore, it can give me a recommendation for a point of interest in Canada. So I can't particularly go visit that place. So that's the only place where point of interest based recommendations can fail and where category based recommendations can work, because it's just giving me the category and I can try to find the best category from that place. So that's about that. So if a user is trying to request for 2 recommendations, the server is going to take the point of interest recommendations as the main thing. It tries to find if point of interest recommendations is there in the vicinity. If it's not, it's going to try to generate the point of interest based on the recommended category. So that's how the thing is going to work. And we finally have our recommendations. So here we see that we only have 2 places in our history, and it tries to recommend us a police station, which means that this is not done from the category based. It's a point of interest based recommendation because some other user has visited these places and next police station. So it tries to recommend that. The restaurant here is a point of interest based recommendation. So here whenever we try to visit, let's say we visit the Tyagaraja Nagar police station, what happens is, I'm trying to set it using Fate GPS again. I'm trying to set it to Tyagaraja Nagar police station. And whenever I open the app, you can see that Tyagaraja Nagar police station is now under the visited place and not under recommendations. And if you refresh the recommendations table in the server database, it shows that it is visited by the user and it's a point of interest based source. So that was the thing. And that was my end of the research outcome. And thank you. And if you have any questions, you can ask me.
Okay, thank you so much for the presentation. Actually, we do have two questions in the chat. So perhaps Anirudh, you can take a look at Kevin and Stephen. They have questions.
Okay. Okay, does it include? Yeah, it does not include those right now. For now, it's just a pure wandering behavior based thing. So whenever it's just going to be purely based on what point of interest is trying to visit after that and after that. Probably we could include this in the future. And can you explain why point of interest based on distance was not used? Point of interest. Can you explain the question again?
I think maybe I'm not quite sure. Stephen may wonder why you say that when you recommend a POI that is out of your 15 kilometers or 50 or 40 kilometers, why it cannot be used?
Yeah. So first of all, the point of interest is the point of interest based recommendation. You had a screenshot that showed. So that screenshot was for offline maps, where Canada versus India. I'll show that again. Yeah. That was for the offline maps here. It's based on cities because cities are more miniature, and whenever you try to download offline maps for that particular city, we can directly the users can import it. And note here that the downloading the offline maps is location data is different from downloading the offline maps. Offline maps is here for the navigation purpose, and location data is your point of interest categories, latitudes, and longitudes. So that's here we are trying to get the tiles. So how the offline map is going to work is it has a SQLite of all the tiles for that particular place, for that particular latitude and longitude, and then it's trying to give that. And there it's trying to give the point of interest history, point of interest name and category there. Was that your question?
Okay, any questions for Anirudh? And while we are waiting for the last maybe one question, I want to talk about Kevin's question. So basically, Kevin, your question is very good. So right now the two algorithm doesn't really right now the two algorithms only consider sequential. So you know, in the data mining, we have what we call time series data mining and the sequential data mining. Both of these data mining techniques, they are considering the sequence. So for example, you go to McDonald's first, and then go to a movie theater, and then go to the Starbucks. Will be a little bit different from you go to Starbucks first, and then go to movie theater, and then go to McDonald's. So that is the sequence situation. So when I purchase something on Amazon today, and then tomorrow I purchase another thing, you cannot consider that if I purchase for example, sleeping bag today, and then I purchase a computer tomorrow. So in that case, sometimes Amazon will consider this kind of purchasing situation is the same just like someone to purchase computer. So when they purchase computer, Amazon will also recommend them to purchase a sleeping bag, which is not true because if you have the sequence difference, then sometimes that will represent the different behavior and the different perception and thought of people. So sequential algorithm, data mining algorithm is what we use right now. What we didn't consider at this moment, just like you say, is about time series. So not only just a sequential, but when that will happen. But as you can also point out, you need to consider a lot of things, because this is Sunday, this is a holiday, and you also need to remember, for example, people, they are coming from different places. They may not consider today is a holiday. For example, if you are Canadian and you go to visit India, today is India's holiday, but for you don't care because you are a visitor. You want to go to the places, do the sightseeing and other things. So even on the weekdays, you want to do that. So there are many things we need to consider, and also for different people, they may have a different time for dining. So for example, right now, I actually have my breakfast almost at 11 o'clock in the morning to 12:30. But for most of people, 11 to 12:30 actually is their lunch time, right? So that is a little bit different from person to person, and you may not be able to identify unless you learn this user's behavior more. So you find its pattern, and you find it goes to usually goes to a restaurant. So when you go to a restaurant, how much time you spend there? If you spend less time, for example, 30 minutes to 1 hour, perhaps you are taking breakfast or brunch. But if you spend more than 1 hour or 2 hours in a restaurant, then maybe you are doing the dinner. So there are many things we need to consider, but that will definitely what we will need to do for the next. So you can see in our next stop recommend the researcher. We started doing this research since 2009. And now Anirudh is taking over the version 3.0. And by the way, I need to tell you, everything you see in his presentation are done by him. Sorry. So beside the algorithm was created by other earlier master student, everything you see here, the website, the landing page, the dashboard, the app, all developed by him. Within 3 months, he started this research in the beginning of June, and right now it's in the beginning of September. So anyway, I don't see any other question coming in. But if you have any question, you are welcome to ask us by email. And so thank you once again, Anirudh, for the good presentation. I'm really grateful to have you on board to doing such an amazing job. Thank you.
Thank you.